Welcome to physics class on human eye and its defect. Now let's go to those defects of eye. Okay, the first one is what this is known as myopia. The first one, the defect is known as myopia. You just remember that this myopia, my means myself, right? You just try to have the mnemonic like this. My means yourself. If the nearest to you is you yourself, okay, so what happened, this sometimes this myopic eye, the eye which is having myopia, we call it that as myopic eye. The person which is having diabetes, we call it as diabetic. Okay, just like that, the defect which is having myopia, we call it that as myopic eye. So in a myopic eye, what happened, this may be termed as what, short-sightedness. Okay, short-sightedness or near-sightedness also. That means this person having what, myopia, can able to see only nearby object very clearly, but cannot be able to see those far off or distant objects. That means this is near-sightedness. That means a myopia, okay, the person having myopic eye can see nearby object but cannot be able to see those far off objects. That eye, the defect of eye, such defect of eye, we call it that eye as myopia, and the eye having myopia, we call it that eye as myopic eye. Okay, now you see that in some objects, okay, for a particular eye, if that object is far away, that can be seen by a normal eye. That far point, we call it that point, distant point, as far point, and that point up to which, the nearest point, I mean up to which an eye can see very clearly, that point we call it as near point. Okay, somewhere here it will be the near point, okay, somewhere here, and the far point, that will be somewhere here. So let me denote it by F and N for near and this F for far. Okay, to a normal, okay, eye, this far point is at infinity. Okay, that to me, that means to a normal eye, means to a non-defective eye, what happened, this far point is infinity, and this near point, we call it this as least distance of distinct vision. Okay, the distance from the eye, okay, up to which the object can be seen very clearly, the least distance, I should say. Okay, the distance from the eye up to this particular point, what we call as near point, and this distance is taken as 25 centimeter. Okay, you can no doubt see, okay, very clearly also when it is coming little bit closer than 25 centimeter also, but there will be a strain in your eye. Okay, so without having any strain, that means without using all your ciliary muscles at all, okay, the least distance, the shortest distance that can be seen very distinctly, that point we call it as near point. Okay, now in this case of your myopic eye, what happened, this myopic eye can see only the nearby objects and cannot be seen your far off objects. So what happened in this such type of what myopic eye, its near point will be little bit closer, okay, than this normal near point. To this myopic eye, its near point may be somewhere here, okay, and its far point will be somewhat also closer. Got it? Both far point and near point will be coming closer toward the eye. So this far point for the normal eye, which is at infinity, it will be somewhat coming here, okay, and this near point to a normal eye for a myopic eye, it will be coming closer somewhere here. Got it? So what happened, that myopic eye cannot see any object beyond this far point. Got it? Why? Because for this myopic eye, its far point is here, not at infinity. So those objects lying far away from beyond its far point cannot be seen. That is why what happened, this myopic eye can see only those nearby objects only, but cannot be seen those far off objects clearly. Okay, so due to that of this such far point and near point coming closer toward the eye, what happen, it cannot be able to see those object which is far away beyond this its far point. Its far point is denoted in this picture by O prime, by O, and this O prime is the normal far point of non-defective eye. Okay, so what happen, the object which is coming beyond, okay, the object which is lying beyond its far point, that means at infinity, all those light rays coming parallel to the eye after refraction through the lens, what happen, instead of converging or instead of having the image form on the retina, what happen, it will be formed in front of the retina. Okay, so what happen, the image will be seen blurred here, okay, onto the retina. Why? Because the image is formed in front of the retina. Got it? So what happen, in order to make this image which is formed in front of the retina, we need to bring it here. Okay, that means this image is formed in front of the retina means what, this focal length of the eye lens is very short. So in order to make a longer focal length, what happen, we need to place or we need to use a double concave lens of suitable power, okay, so as to focus the image coming from the far off objects onto the retina. Okay, this lens we call it as divergence lens. Okay, your eye lens for the myopic eye, it is having what, short focal length. So short focal length means what, its converging power is very high. So in order to have this converging power less, we need to use what, diverging lens. If it converges very at a short distance, then by using this divergent lens, what happen, it will become diverse and it will be focused onto the retina. So the remedy of myopic eye is the use of the double concave lens of suitable power. So by using such concave lens of suitable power, whatever the light rays coming beyond its far point, okay, whatever the light rays coming from the object lying beyond this far point can also be focused onto the retina. Okay, so what happen, your image will be seen here inverted. Okay, the inversion of this light ray, it will be sent to the brain through your optic nerve, and that brain will analyze it and it will be seen as the object is. Okay, even though the image is formed inverted here, but the brain will interpret that it is erect. Okay, like that. So what is the cause of this myopia? The cause of this myopia may be what, your eye lens, okay, is having more converging power, or you can say that the relaxing power of the ciliary muscle is less. Okay, the first one is what, it is of high what, converging power of the eye lens. It is due to the high converging power of the eye lens. Okay, instead of converging here onto the retina, what happened, it converges here. That means it is having high convergence. Okay, so the first cause is what, high convergence of the eye lens. The second, you can say, the second is what, it is what, relaxing power of the retina is less due to the less relaxing power of ciliary muscles, you can say. Got it? Had it been these ciliary muscles pull outward by relaxing its ciliary muscles, I mean, what happened, this eye lens will be flattened. Okay, if it is flattened, then what happened, focal length will be longer and it will be focused here. But here it is what, focal length is very short. The actual focal length will be this much. Okay, so what happened, focal length is shortened, or you can say that this is due to the what, less relaxing power of the eye lens, I mean ciliary muscles. Okay, or the third one is what, due to the elongation of this eyeball. If this eyeball, which is actually this is of the normal size, for example, if this eyeball means the eye, okay, the size of the eye, if it had been enlarged, okay, we call it that as elongation of the eyeball, then naturally your retina will be here, so your image will be from in front of the retina here like this, right? So what happened, this is due to the third one, you can say due to the elongation of the eyeball, you can also say like that. Okay, and these are the causes. The first one is what? Due to the high converging power of the eye lens. The second one you can say due to the less relaxing power of ciliary muscles, and the third one you can say this is due to the elongation of the eyeball. Okay, and the remedy for this defect is what? By using a double concave lens of suitable power. Got it? Yes, let's see the next type of the defect, that is known as what? Hypermetropia. And this hypermetropia, we can also call it this as what? Long-sightedness or far-sightedness, you can also call it. Hyper means high, high means long. You can have that mnemonic like that. So hypermetropia means what it is. Either you can call it this as far-sightedness or long-sightedness. It will be just opposite of that of myopia in this case. The near point and the far point will be going beyond or far away from its what? Normal near point and far point. If your normal point for a non-defective eye is this one, for a normal human adult, okay, if the near point is this n prime, for a normal person it is also written here, okay, if this is the normal point, that means the distance between this eye and this near point, it will be 25 centimeter in the case of non-defective normal eye. Okay, but to a hypermetropic eye, what happen? Its near point will be go beyond this, okay, more farther away from this. So what happen? It may be coming out to around of 1 centimeter, 1 meter or 2 meter or 3 meter like that. Okay, if it is gone beyond here, then what happen? Those objects which are of this lying here somewhere here, it could not be seen very easily. You might have seen some elderly people that while reading the newspaper, they may place the newspaper far away from their face and they will look it far away like that. Have you seen? So such type of those aged peoples, in which the newspaper is placed very far away from himself, by taking that newspaper far away, that is nothing but that is having hypermetropic eye, because to him he can see those far off objects very clearly, but he could not see those nearby objects very clearly. That type of defect we call it as hypermetropia or long-sightedness, or you may call it as what? Far-sightedness also. Got it? So what happened in that case of this hypermetropic eye? Instead of forming the image here onto the retina, rather it will be formed behind the retina. Okay, that means in this case what happened? The converging power of the eye lens is less. If it had been more converging power, then this light ray which goes behind the retina, it would have been focused onto the retina, right? So what happened? In order to bring this near point of the hypermetropic eye to that of this normal near point, okay, we need to use another lens, okay, known as double convex lens of suitable power, so as to converge the light ray onto the retina, okay, instead of going away, far away like this. If it is going far away, then it is less converged. So if it is going to bring toward nearer and nearer, then means you need to bring short focal length. Okay, shorter focal length, that means converging power should be more. So in order to converge more, we use another similar convex lens of suitable power. Okay, so let's see what are the causes for this your defect of eye for this hypermetropic eye. Now it will be just opposite, as I said. Okay, in the case of myopia, the first cause is what? The first cause is what? This is due to the less converging power of the eye lens. Okay, less converging power of the eye lens, that is the first point. I will not write it because it is very difficult for me to write it onto the screen. Okay, so the first cause is what? Less converging power of the eye lens. The second is what? This is, if it is going to be contracting here, then it would have been what? Shorter focal length like this, thicker, and it will be shorter. Okay, and the second point is what? Less contracting power of the ciliary muscles. Okay, less contracting power of the ciliary muscles. It may be due to the old age, or it may be due to some disease, or it may be due to the defect, okay, after having some accident or some certain blow onto the eye also. Okay, so that means the second one is what? Due to the less contracting power of the ciliary muscles. And another, what, the last one is due to the what, instead of elongation, it will be due to the shrunkening, okay, shrunk, you know, due to the shrunkening of your what, eyeball. Okay, that means the eyeball become decrease in its size. We don't know whether it may be due to that of the less amount of your vitreous humor also, it may be. Okay, so, I forgot to tell you that liquid, okay, which fill those inside the lens and inside the eye, vitreous humor or aqueous humor, this gives you the spherical structure. Okay, this liquid maintain the spherical structure of the eye. Got it? So if that what, your vitreous humor or aqueous humor is less in amount, naturally what happen, your eyeball will be shrunken, and naturally your retina, which was there in the for the normal eye, it may be somewhere here onto this retina. Okay, whatever the image formed there, it will now form what, behind the retina. Got it? So it is like it. Suppose if your actual size is this much in the normal eye, for example, then the image is focused onto the retina here. If this eye lens is okay, not eye lens, if the eye is shrunken due to the less, okay, that liquid inside it, vitreous humor, then what happen, this eye will shrunken and it will be coming to somewhere here like this. So the retina will be here now, instead of here, it will be here. So what happened, the image will be formed behind its retina, right? That is a thing happening here. So the cause of this is what, the first one is what, less converging power of the eye lens. The second is what, due to the less contracting power of the ciliary muscles. And the third is what, due to the shrinking of eyeball. Okay, and the remedy for this defect is what, using of the double convex lens of suitable power. Got it? Let's see the next one. The next one is nothing but this is presbyopia. I'm not having that presbyopia, the diagram for that one. This presbyopia, the sole cause for this is due to aging. Okay, due to the old age. So when we are strong enough at our youth stage, what happen, when a full grown adult, what happen, its muscles will be strong. Naturally, what happen, its ciliary muscle will be also strong. But due to the old age, what happen, this contraction and relaxation of the muscle will be weakened, and so what happen, both relaxing of the ciliary muscle as well as contracting of ciliary muscles will be weak, and so that person cannot be seen very easily, both nearby objects as well as also far off objects. So that type of defect in a human eye, we call it that as presbyopia, and the cause is what, aging. The defect is the remedy for this cause is what, we need to use it bifocal lens. You might have seen in to some person wearing spectacles that they are using two type of lenses like this. So let's take it that I will draw a diagram for a spectacle. Okay, just try to watch it, but I'm not very good enough while drawing these diagrams and all, but still I just try to give you what concept of it. Suppose if you take it that this is the what spectacle, then you might have seen that using different type of lenses onto the same spectacle. We call it that type of what lenses as bifocal lens. This lower part is also lens. Okay, this lower part is also lens, the upper part is also lens. So they are using two type of lenses, so we call it that type of lenses as bifocal lenses. Now this one is using for observing what, observing for nearby objects. For observing nearby objects, that will be the remedy for hypermetropia. Don't forget this. Okay, it may ask also in the examination, what type of lens is used in the lower part and what type of lens is used in the upper part, like this. So this lower part of the lens, it is used for observing nearby objects. Okay, for observing nearby object, that will be the remedy for hypermetropia. So in the case of what, for observing lower part, we have to use it what, in the hypermetropia we use convex lens, right? So the lower part of the lens must be what, convex lens, and the upper part will be what, then concave lens. Am I right? So the lower part that is going to be used in the case of presbyopia, the remedy is what, bifocal lens. The lower part is what, convex lens, and the upper part is what, the concave lens. Got it? So in that bifocal lens, we use both concave as well as convex. Okay, so the lower part is convex and the upper part will be concave. This will be convex, got it? But the upper part of the lens, these two will be what, concave. Concave lens of suitable power, okay, will be used in the upper part of that bifocal lens, and the lower part will be of convex lens of suitable power. Got it? Don't forget this one. Okay, this is very important, right? Let's go to the next part. The fourth defect is what, that is known as astigmatism. In this astigmatism, it is not the defect of the eye lens. Up till now, whatever we talk about what, both the myopia, then hypermetropia, then presbyopia, all those are the defect of this, the converging power or relaxing power of ciliary muscles, okay, and that of the size of the eyeball. But in the case of this astigmatism, it is not due to the converging power or what, increasing in the size or relaxing power of ciliary muscle. It is not at all with that one, not related with that one. Rather, in the case of this astigmatism, the cause is what, it is due to the irregular shape of that spherical shape of your eye. Got it? That means your eye lens. It may be due to the irregular curvature, spherical curvature of eye lens, or it may be due to the irregular curvature of your eyeball. Okay, to that having this astigmatism, okay, to that person having this astigmatism, suppose you are having a mass of wire like this, okay, mass of wire, horizontal lines and the vertical lines like this. To a normal person, all these lines, if you are observing somewhere here, okay, to that normal person, you will see those horizontal lines as horizontal and the vertical wire will be seen as vertical. But to that, okay, having this astigmatism, what happened to that person, he may see that this portion where he observe it, it may be seen little bit curved there, okay, like this, and he may see the horizontal line as horizontal, but the vertical line where at the point of its observation, the vertical line may be curved like this. That means it seems that the image form for this portion has been distorted, okay, distorted. So what happened, he may see the vertical lines curved like this, he may see the horizontal line also even curved, okay, it may be different for different person, okay, he may see the horizontal line also curved like this. Got it? So such type of defect, we call it that as astigmatism, and this is due to the irregular spherical curvature of the eye lens. Okay, got it? Either the first one is what, irregular curvature of the eye lens. Try to note down, okay, I will not write it here. This is due to the irregular spherical curvature of the eye lens, or it may be also due to the irregular curvature of your eyeball. Okay, if it is irregular curvature in the eye lens like this, then what happens, such type will be formed. Okay, this is about the lens, and onto that retina, okay, it should be spherical in shape, but if that irregular curvature of the eyeball, due to that, what happened, retina may be also curved. Got it? So due to such, what happened, your irregular or distorted image will be formed, and that we call it as what, astigmatism. Got it? So the remedy for this astigmatism is what, by using what, cylindrical lenses of suitable power. Okay, I'm repeating again, the remedy for this astigmatism is what, it will be the use of cylindrical lenses of suitable power. Got it? And the last one, that is known as cataract, and this cataract is nothing but, you might have seen some elderly people that instead of observing his or her eye as black in color, rather you might have seen some white, okay, milky spot seems to be there onto its eye. That type of eye is known as what? Cataract. And it can be what this cataract is nothing but this is the cloudy or milky structure present onto that eye lens or in between that cornea and the eye lens. And this cataract may lead even to a complete blindness, okay, because light cannot pass through those milky substance or white substance, okay. It will block all the incoming lights and it may not see those objects very clearly, so it may lead to complete blindness also. But it can restore very easily its vision by having that operation of this what eye, and it can remove all those milky or white structures present there, okay, and it can restore its vision again. So that type is not included actually in by using these lenses and all. So the remedy for this is what? It is by operation only, okay. So those are the very much defect of all those different types of defects. And with that we will conclude our class here. Thank you.